Hey guys, welcome back to the channel. My name is Zahir, and today we will be looking at the third video in the MCP series. I have essentially created a playlist. This is the playlist. You can go through each of the videos in sequence and understand how to write custom MCP client and servers. All right. Uh, Today's problem statement is something that a kind subscriber essentially shared with me. The subscriber wanted me to essentially write the client that I was writing, essentially a script, but to write that using ASGI framework. And that's exactly what we will be doing. In fact, I've already done that. I'll be walking you guys through the code now. All right, so before I show you the code, I want to tell you how that is going to work. So we'll be using Streamlit as a UX layer, and we'll be using FastAPI as an API to essentially power the Streamlit application. This is going to be our MCP client essentially, right? It's Streamlit will have a chat-like interface, and FastAPI will essentially be the API that takes the queries from the Streamlit UX and processes that. How does it process? This is where the FastAPI essentially becomes an MCP client and talks to the MCP server or establishes the connection with the MCP servers. Now, interestingly, what I have done here is I have added both STDIO servers and the SAC servers as well. And I've written a very generic platform where you can add as many number of STDIO servers and SAC servers, and you should be able to essentially talk to multiple tools and resources using this particular client here. Okay, but sticking to the series that we've been building up, which is basically using STDIO server, that is the BMI server that we wrote initially, and the SAC servers that we wrote in the previous video, we'll be using the same scripts. However, we will be writing this particular part, that is the client, an ASGI BS client, that is essentially going to talk to these servers. Okay, let's get started. I am going to show you VS Code now. Let me go back to the directory. I've been testing it, but what I'm going to do now is kill all terminals and start everything from scratch. Now, I think I'm going to keep some on because I think it makes sense. Okay. The new addition to the directory, let me close all. I'm sorry, guys. And increase the font size. All right, the new addition to the directory from what you have already seen in the repo. If you haven't, I strongly recommend you check out the MCP Labs repo in my GitHub profile. I'm going to share that, share this particular link in the description. You can go through that. What we'll be doing is adding another directory, and this is the directory MCP chat UX STDIO SSE, and it'll have two files. The first file essentially is the FastAPI client. And if I go back to the illustration that we just showed, I'll create a file called MCP. Let me just check the name, MCP client API.py to essentially run a FastAPI application. And we'll also create a Streamlit underscore chat.py to essentially run the Streamlit application. It's essentially UX. It's a UX framework, right? All right, it's a very lightweight UX framework. So let's look at the MCP client API. The MCP client API essentially has a lot of code copied from the MCP clients that we've written previously, essentially the MCP client SCC chat.py from the previous video. It's part of this particular server. Okay, we will be taking the best parts from that. However, what I've done essentially is I've created two or three classes. One is just a Pydantic class called toolmap, which is essentially, it has three attributes. One is server type, which is basically a string. It has tool, a dictionary, essentially, which is going to have the server name, the MCP server name, and all the tools associated with that particular server, and parameters. For example, the parameter in this case can take two, right? The STDIO server parameters and string, because we don't know, because we intend to create, a generic list of tools and MCP servers, we essentially have to pass the stdio server parameters or string, that is the SSE URL, to the relevant class. I'm going to show you what the those classes look like. All right. So we've just created this tool map. It's a Pydantic class. The next class that we will create is a tool list class. Essentially, what this tool list class does is, depending on the kind of server we have, that is either a SEC server or stdio server, it essentially creates a client session and then just simply returns the tool. However, what it does is it returns a dictionary, which with the key being the server name and obviously the value being the list of tools associated with that particular server. Okay. And this is the method to essentially get the list of SSE tools. We have a very similar method to essentially get the list of stdio tools here. Okay. And this method does the same thing. Given the parameters, it will essentially return the server name, a dictionary of the server name, and the list of tools associated with that as a value. Okay. It's a very simple implementation, as you can see. But the interesting bit is this, and I want you to pay close attention to this part. This is where, it uses the tool map that we just created, where it is essentially using the MCP server config an instance of this particular config class is something that I will show you, in a bit. It is then essentially looping through the the tool map instance, or sorry, getting the tools from the stdio get tools in case if it is for stdio server parameters, and for SSE URLs it is getting it from the SSE get tools method, and then it is basically creating a list of all the tool maps, and we're calling it tool context and returning that particular tool. Simple. It's a very simple implementation. The other one, as you can imagine, is once we have the list of tools and we have identified which particular tool, a particular task can be executed with, there is a class here called execute tool. Very simple, very similar looking methods here. Call the tool. However, this particular the call tool method for a specific server, in this case stdio, takes a query, the original query from the user. Memory is essentially the conversations that we've been having, and the tool call, which is basically the tool and the parameters for that arguments for that particular tool as input, and obviously server parameters being here the server parameters that the stdio client needs to essentially communicate with. Okay. A similar implementation for SSEO, SSE cool tool as well. The same list of parameters, and in the case instead of server parameters, we are obviously sending the SSE URL here so that the SSE client can communicate with the SSE URL, and you should have that here. Okay, it's a very simple implementation. I'll obviously walk you guys through this, and you will see how this is all pieced together. One more class, which is called the MCP server config, and as I told you earlier, we'll be creating a generic client which can take in as many SEC servers or stdio servers and essentially work with it, right? So this is a very simple implementation. We'll be instantiating empty server parameter list and SSE URLs in the constructor, and we'll basically create a method to add server parameters and add it to the instance of server parameter list. And similarly, we'll have the add SSE URL here, as you can see. And obviously, this is to retrieve the added SSE URLs and stdio server parameter list here. All right. Now, let me go back here. Now, instead of essentially, walking you guys through the code line by line, what I'll do is I'll run this, and we'll debug this together and understand how everything, essentially is working. Okay. So I have, remember, we will obviously not be leveraging, we will not be rewriting the BMI server or the MCP server that we have obviously written, but for chat instance, we'll be using the same one. So what I'm doing right now is I'm running that particular server here, bmi underscore server.py. I'm already running that here. Let me show you that. I think this is, I'm sorry, guys. Yeah, this is the MCP server SSC, which is running here. MCP server SSC is basically, this is the server sent events based MCP server, which we've written. So if you want to quickly see this, this is how it looks like. And it has two tools, a time tool and a weather tool. The name of this particular server is weather and time server. There is a very detailed video on this from, in the series. You can check that out. I've explained each and every line here. And this is basically running on FastAPI, and I've already started this particular file and it's running. I've been testing this. That's why you see this here. The other server that I want to obviously run is the BMI server. I have stopped this for now, but I'm going to run it again. I think I've run that already. So yeah, it is running as well, which is here. So I have two servers running. That is a BMI server, which is a stdio server. If you want to see this, let's quickly see that as well. As you can see, this is a stdio server, and I have the MCP SEC server running here. So both these servers are running. Now, what I need to do is run the Streamlit chat, which is basically the UX that we've created, a simple chat-like interface. And this is also already running. I'm going to refresh this, and this will start connecting with the FastAPI client. Now, instead of running the FastAPI client, what I intend to do is basically debug this line by line so that you can essentially see the flow of this particular method. Okay. All right. So I'm going to start this debugging this particular file. And okay, I don't want two instances of this. I'm going to kill this. Okay, we'll just wait for this to get started. Take some time. Interestingly, it's taking a lot of time. Oh, it started. I'm so sorry, guys. All right, it has started, as you can see. And the first thing that we're looking at is I've created a list of SSC URLs here. Now you can imagine this either coming through a database, the list of URLs, or you've created a config file and you have all the list of SSC server URLs that you can actually work with. And because I'm running this locally, I'm on port 8100. I'm utilizing this. All right. And I've also created a list of STD server parameters. So now imagine that you have several files running locally, or you're basically running this remotely as well. You can essentially add that files or STD IO server parameters like this. This is not obviously a standard way of doing this, but because this is an educational video, you can write this using the best practices. But I want you to know that you can actually add as many stdio server parameters and SSC URLs and work with this particular client. Okay, let's go to the next method. Obviously, I need to give the arguments to run the stdio server parameters. It's very simple. I want Python to run this particular file. That's the command. All right, so that's done. Now I'm going to instantiate the MCP server config clients. The MCP server class, after instantiating this, I will add the stdio server parameters to the using the add server methods to this particular instance, and I will also add the SSC URLs. And I'm doing this when I'm starting the application so that I have this instance of this particular class created right at runtime. Okay, so now the UVCon server has started, and I have this particular Streamlit application running. Now what I will do is go back to the Streamlit application. I was running this already. I'm going to refresh this now, and we will see that the WebSocket chat app has started, and Let's quickly come here. So I'm running in this in the debug mode. I have written this method. As you can see, this is essentially the app. This particular decorator is basically the routing decorator, where I'm essentially taking in requests that is using the WebSocket method to essentially communicate with this particular client now. All right. So now what we will do is the client has. Let me just talk about this. The client has essentially started a WebSocket connection here because we need to make this a two-way communication channel. So the Streamlit application has created an instance, or essentially called the chat endpoint. And what I intend to do is I want to essentially use a WebSocket connection, create an instance of the WebSocket connection, and essentially now work work with the simple the several methods or classes that we've written. Okay, so let me go back here. The Streamlit application has hit this chat endpoint, which is what we are showing here, so that the WebSocket connection is established. Once that is done, we will first create an empty memory memory object. It's essentially a list. If you remember from the previous video, we used this as a conversation history, right? Then what we do is we'll create an instance of the tool list class, and I'm going to get to that part in a bit. So we'll instantiate the tool list class. We need to do this so that we can essentially get the context of the tools that we have at our disposal. And how do we do that? We will essentially call the get tool context method. Now let's see what the get tool context method does. Remember, we created the MCP server config instance of this particular class. This is the same instance, and what we are doing right now is essentially getting all the server parameter list, and we have added this while instantiating or starting this particular UVCon server, right? So we have the server parameters. It's a list essentially. We also have the list of SSE URLs, right? So we know now that we have the list of all the MCP servers that are available at our disposal now. Now, what we will do is we will essentially create a tool map so that we know what is this type of server that we are working with, what are the tools that we have at our disposal, and what are the server parameters that we need to essentially work with. Okay, so server parameters, I'm using this in a very generic fashion, but essentially server parameters is both for stdio as well as the SEC tools, right? I'm saying that you can think of that as I'm talking about that being the attribute of this MCP server that we are working with. Okay. All right. Now that has been established, what we'll do is we will essentially get all the tools from so we'll essentially get all the tools now given the server parameters here. So I'm obviously using the stdio tool, stdio get tools method here, and it's the same implementation that you've seen previously. What I'm doing right now is initializing the session using the stdio client, and once the session is established or created or initialized, I will essentially simply capture all the tools and the server name as a dictionary. So the key being the server name and the tools essentially being the values here. So if you see what is being written here, and you will see that in a bit, stdio tools is essentially the key is BMI server, and the list the value is a list of tools, right? All right, that was simple. So we've created the instance of the toolmap class. The toolmap class has obviously the server type here. I'm obviously hard coding this. You can do this dynamically or create a constant. The toolmap contains the server type stdio. It has a tool dictionary, which is BMI server. Remember, it could have a key value combination of several servers here. and the parameter, server parameters that is part of this particular tool map instance, okay, which is basically what we have sent from the list of stdio server parameters that we captured on while creating the instance of this particular application. Okay, so this is done. Similarly, we do the same with SEC tools. We have the list of tools, and once you get the list of tools, here's how the final mapping looks like. I have a tool map. The server type is SSE. The tool is weather and time SSE server, which is basically MCP server, and the list of tools associated with that particular server. Okay. Now we have basically created a list of tool maps, which is basically both for stdio server as well as SSE. That is established. I've printed that on the screen, as you can see, and we have created the tool context now. We'll move to the next part now, which is basically, we have established all the MCP servers and tools that we have at our disposal. Now we'll start taking in the query from the user. Okay, so as you can see, this particular command is essentially awaiting a request from the user. So my request would be calculate BMI for a person with so and so height and weight, and I'm going to click on send, and it is basically come here. It has received the user input is calculate BMI for a person with height. Save. We have that established, and we'll obviously instantiate or essentially call the chat agent method that we have used previously in the last video. But again, let me walk you guys through this. The first thing that we'll be doing is we'll be creating a list of tools from the tool map list that we've created. We need to pass this to the LLM to identify the relevant tool needed for the kind of query or the kind of task that the user has given to us. Okay, so I'm going to first create a list of tools here. We have the list of tools, and if you look at this particular object, it has 3 tools. One is the calculate BMI tool, the second tool is time tool, and the third one is weather tool. It's not at this point in time, we are not worried about which kind server that we are dealing with. I just want to give the context of the tool, the description of that particular tool, and the schema of that particular tool to the LLM. Let me print that, and you will see this is how it looks like. For example, for the calculate BMI, the tool, this is the name, the description looks like this, obviously, and the schema of that particular arguments looks something like this, right? All right, with that established, I'm going to print the prompt. Get prompt is again from the last video, as you have seen, it's basically the prompt. I'm going to show you that, where we send the list of particular tools and the query from the user. And the context is basically conversation history that we've had, and I am expecting the LLM to basically return a JSON object that looks something like this. Given the query, identify the tool and also create the arguments for that particular tool. That's the command essentially. Okay, so I'm gonna go back to the part here. We have essentially, now we'll call the client, LLM client, with that particular prompt. The LLM also has returned a response, and the response looks something like this. It has identified the name to be the tool name to be calculate BMI, and it has also created the arguments for that particular tool. Awesome. And you can see this is the the tool and the arguments. Perfect for the query, and it's perfect for the query, right? So now what we'll do is we have identified the tool name. Now we need to essentially execute the tool. How do we do that? Pretty simple. So we create an instance of the execute tool. Let me go to the execute tool. I did a quick walkthrough of this in the beginning of the video, but let's look at this again. The execute tool has 2 methods primarily, which is basically stdio call tool and the very similar looking SSE call tool. So if the server type is SSE, we call this method. If the server type is stdio, we call the stdio call method. And what we essentially will do is we'll pass query, the conversation history, and also the tool call dictionary, that is the tool name as well as the arguments for a tool, and the server parameters, whatever we need to essentially connect to the essentially the parameters we need to connect to the MCP server. Okay, let's go back to this particular line now. So we have the tool context, we have the tool mapping done. So I will iterate through each and everything now. Now what we know that we have identified, the LLM has identified the tool name to be calculate EMI for our query. The first thing that we will do is we'll check, we're iterating over, let me take a step back. Tool context is basically a list of tool map, as you know. We're iterating over each tool context, or iterating over each tool map instance of the tool map class. Okay, and we are identifying if the tool name that the LLM identified is present in the list of tools that that instance of tool map has, and we'll see if it does. In this case, it identified that there is a tool name which is present in the tool map instance that we have just we are iterating on, or we are currently present on, and we'll see if the tool map that we identified, the server type is SSC. Let's see what is the tool map here. The tool map server type here is stdio, so it'll go to the next else if, and if the tool map server type is stdio, it'll essentially call the execute tool ops stdio call tool instead of SSC call tool, obviously. So we will see how it is doing that. Let's see what the parameters are. Query is obviously the original query, calculate BMI for a person. Memory is the list of conversation that it has had. At this point in time, it is empty because this is the first iteration that it is going through. Tool call is essentially a dictionary where we saw that the value is the key is the tool name, and the value is tool tool call essentially has two fields, the tool being calculate BMI, arguments being the arguments that we need to essentially send to the LLM or to that particular tool. This was, remember, this was generated by the LLM, as you can see here, right? And server parameters is how do I connect to the servers? You can think of server credentials essentially. In this case, it's simply the command and the arguments, which is basically the file name that I need to call. Okay, simple. So I'm gonna F11 now and see how that is being executed. Simple again. We create the instance of that particular client and initialize that. And once the connection is established, we will see that we will be calling the, instead of get tools, we are calling the call tool method, because we know that that's why we already know what tool we need to call, because we have obviously passed it here. So tool call of tool is basically the argument we need to call tool, which is the name of the tool and the arguments for that particular tool. Simple. And the result is already there. I'm going to print the result. Now it is saying that the BMI is 22.8, and I'll only capture the result now, the final process result. And once that is done, let's go back here. The result is out, and the result is the BMI for a person with a weight of 70 kg and height of 1.75 is approximately 22.86. Awesome. And because we obviously have executed the tool, we'll break out of the loop and we'll return this particular result. And once this is done, we will simply empty user input because we want to iterate on the loop. So in the next loop, we essentially, the next time we essentially wanted to take in the response. You can actually avoid doing this. I was just testing this. All right, so I'm adding the response of the LLM or the agent to the memory or the conversation history, and I'm checking what did the LLM return. The LLM returned a response to user, okay, which means that I need to basically send the response back to the user. I'm logging this for us to check, and response from the agent is the BMI for a person with a weight of 70 kg and height of 1.75 is approximately 22.86, and we'll broadcast this back to the client using the WebSocket manager. And if you see, the output is here. The BMI for a person with a weight of 70 kg and height of 1.75 meters is approximately 22.86. Awesome. Now, this is exactly how you can actually work with multiple servers, MCP servers on a single client, and you can try the query and share your responses with me, and let me know if you have any doubts. But this is it, guys. I hope this was useful. I'm going to push the changes here to this particular repo in a bit, and you should be able to have access to all the code that I just shared. Okay. I'm hoping this was useful. Please share it with your network. Share your feedback with me. uh, it motivates me to basically create more such content, go deeper into writing these servers from scratch instead of using what is already been done, so that we strengthen our understanding and fundamentals, and most importantly we enjoy what we are doing. So thank you so much, guys. Thank you so much for spending the time on this in this particular series, in this particular video. I'm hoping this was useful. If you found this useful, please share it with your network, like this particular video, and subscribe to the channel. Thank you so much. You have a good one. Bye.